Hello, you are watching Engineering Made Easy. In my last lecture, we discussed about the process of modulation. You got an idea about what is modulation and what are the various types of modulation techniques. But it is very important to know why the process of modulation is required. Is it possible to transmit a signal without modulation? If it is possible, then what are the benefits of it, and what is the need that encourages us to adopt modulation process? But before telling you the importance of modulation, let's revise the definition of modulation. We have discussed that modulation is a process by which some characteristic like amplitude, frequency, phase, etc. of a high frequency carrier wave is varied in accordance with the instantaneous value of the message signal. So let's first write down this definition. The definition of modulation. So we can write here as modulation is a process by which some characteristic like amplitude, frequency, like amplitude, frequency, phase, etc. of a high frequency carrier wave of a high frequency carrier wave is varied. Okay, in accordance with the instantaneous value. In accordance with the instantaneous value of the message signal This message signal is also known as modulating signal or the baseband signal. Okay, so now let's discuss the need for modulation and its benefits. So here I am first summarizing and later we will deal with each of these benefits and need of modulation in detail one by one. So first let me write here the benefits and need of modulation. So the benefits of modulation. Let's write these benefits of modulation in the next page. That would be better. benefits of modulation. So what are these benefits? The first benefit is to remove interference problem. Okay, to remove the interference problem. Second one is the practical height of the antenna. The practical height of the antenna. Third one is the possibility of multiplexing. We will deal with each one of them in detail. I will explain you all these points in this lecture video. The fourth one is the long distance communication. These all are the benefits of modulation. And the fifth one, the last one, is the improved signal quality at the receiving end. Improved signal quality at the receiver, or you can say at the receiving end. Okay, so these are the 5 points, or you can say 5 benefits that we will deal. These are the benefits of modulation. So let's start with this first one, how it helps in removing the interference. So to remove, let me first write down the first point here. To remove interference problem. Okay, this is the heading. As we know that in the process of modulation, the message signal is superimposed over the high frequency carrier wave. We have seen it earlier. So hence, by modulating the low frequency message signal onto the high frequency carrier wave, it becomes possible to allocate a separate frequency band to different message signal transmissions. Hence, many stations can transmit their message signals simultaneously without any interference by using carrier signals of different frequencies. Did you get this? Okay, let's write it. What I mean to say, how modulation helps in removing the interference problem by allocating a separate frequency band. It allocates a separate frequency band to different message signal transmissions. To different message signal transmissions. Okay, so many stations can then transmit their message signals simultaneously. Because of this, many stations can transmit their message signals simultaneously without any interference, without any interference. Okay, so for example, the audio signal lie in the range of 20 Hertz to 20 kilohertz. This audio signal lies in the range of 20 Hertz to 20 kilohertz. What is the range of audio signal? 20 Hertz to 20 kilohertz, means 20 Hertz to 20,000 Hertz. This is the range of audio signals. So without modulation, the transmitted signals of all stations will get mixed up. But by shifting these message signals into different frequency ranges by modulation, this problem of interference can be solved. Okay? Now let's come to another benefit of modulation, the second one, which is the practical height of the antenna. The second point that we will discuss now is practical height of the antenna. So how it affects the height of antenna, how modulation affects the height of the antenna. Since in wireless communication, antenna is used at the transmitting end and also at the receiving end. One very important thing that you should notice is that the transmitting and receiving antennas must have lengths or the heights comparable to a quarter wavelength. It means the lambda by 4 of the frequency used for transmission. Let me write it. What did I say? The transmitting and receiving antennas and receiving antennas must have lengths comparable to a quarter wavelength. Quarter wavelength, which means lambda by 4. Here lambda stands for the wavelength, so the lambda by 4 of the frequency frequency used for transmission. This is very important fact, that it should be equal to the lambda by 4 of the frequency used for transmission. So the height of the antenna should be lambda by 4. Okay, here what is lambda? Lambda is the wavelength of the frequency that has of the signal that is used for the transmission purpose. So as we know that since we know that C is equals to lambda into frequency, this implies that lambda is equals to C by F. So I'm replacing lambda with C by F, so it becomes C divided by F 1 by 4. Okay, clear? So here what is C? C is the speed of light in vacuum. Its value is equals to 3 into 10 raised to the power 8 meter per second. 3 into 10 raised to the power 8 meter per second. So we can say here that since we know that C is a constant and 4 is also a constant, so we can write it as the antenna height is inversely proportional to the frequency. Okay, so as the frequency increases, the antenna height decreases. As the frequency used for transmission increases, the antenna height decreases, as it is inversely proportional. Here the modulation can help us in reducing the size of the antenna by shifting the message signal to high frequency range. Because we know that in modulation process, the message signal, that is the modulating signal, is superimposed over a high frequency carrier wave. Hence we can say that as frequency increases after modulation, you can easily say here that after modulation, as the frequency increases, it results in the decreased height of the antenna. Okay, after modulation, as the frequency will increase, as we will superimpose the message signal over the high frequency carrier wave, so the modulated signal will be of higher frequency, much higher frequency. So as it is inverse in relationship, its antenna height will reduce. Let's understand it with the help of an example, why we need to reduce the height of the antenna and how much it can help in reducing the antenna height. Let's suppose I'm taking an example to explain you. For example, let's suppose we have a message signal having highest audio frequency of 4 kilohertz. Here is an example. In this example, I'm taking an audio signal audio signal which has a frequency of 4 kilohertz, 4000 hertz. This is the frequency of that audio signal. So I will use that formula to calculate the height of the antenna required for its transmission. So it would be, as we know that height h was lambda by 4, which means lambda means c divided by f 1 by 4, which is equals to 3 into 10 raised to the power 8. It is in meter per second. This is the speed of light in vacuum. 4 kilohertz. As I told you, it is 4 kilohertz. Frequency is 4 kilohertz. So I'm replacing f with 4 kilohertz. 4 into 10 raised to the power 3. It is in hertz then into 1 by 4. Okay. So it comes out to be equal to 0.187 into 10 raised to the power 5 meters, or 18.7 kilometers. Oh my god, it's too big and impractical height of the antenna. Is it possible that we install an antenna of 18.7 kilometers? Not possible, not practical height. So we need to devise a mechanism to reduce its size, reduce its height. So here the role of modulation comes. So now let's use the modulation process to reduce the height into practical limits. Here suppose we translate this 4 kilohertz audio signal that we have used before, the 4 kilohertz signal, into 5 megahertz by the modulation process. So I am translating this 4 kilohertz before modulation. It was 4 kilohertz, but after the modulation process I'm taking it 5 megahertz. I'm using high frequency carrier wave, so this modulated signal is of 5 megahertz, which is much higher than the modulating signal frequency. So now this let's calculate the height with this 5 megahertz. Height is equals to lambda by 4, which is again c by f 1 by 4. On placing the values here, frequency is 5 megahertz. Mega means 10 raised to the power 6. 5 into 10 raised to the power 6 into 1 by 4. Very simple maths. It comes out to be 1.15 into 10 raised to the power 2 meters, means 15 meters. Okay, 15 meters is height, is a practical height. So you can use the modulation technique here to reduce it to practical heights. It has reduced, as you can see, initially it was 18.7 kilometers. It has reduced to just 15 meters now. The third point, let's discuss the third benefit of modulation. What is this? The third one is the possibility of multiplexing. Have you ever heard this multiplexing? Okay, let me tell it to you. Multiplexing can be defined as a process by which two or more signals can be transmitted simultaneously over the same channel for communication. Let me write it down. Multiplexing can be defined as a process by which two or more signals can be transmitted simultaneously over the same channel. Transmitted simultaneously over the same channel. Okay, over the same channel for communication. You can say over the same communication channel. Okay, with the help of modulation, it is possible to allocate separate frequency for different message signals by using carrier waves of different frequencies. So even on transmitting many message signals over the same channel simultaneously, they don't get mixed up. Okay, they don't get mixed up even we are transmitting many message signals over the same channel simultaneously. This is called as the frequency division multiplexing. This is known as the frequency. This process is known as frequency division multiplexing, also known as FDM in short. Frequency division multiplexing. Multiplexing may be of another types also, like time division multiplexing, but here we are not going to discuss these. We will have separate lectures over these types of multiplexing and introduction of multiplexing. So for now it's enough. Okay, so the modulation helps us in this multiplexing process. Now let's come to the fourth one, the long distance communication. This is the fourth benefit. Long distance communication. Fourth benefit of modulation, the long distance communication. High frequency signals are attenuated less in comparison to the low frequency signals while propagating through the channel. This is a very important thing that you should know, that high frequency signals attenuate less as compared to low frequency signals. Okay, this should be kept in mind. So since we know that modulated signal has higher frequency, okay, than that of the message signal, since in modulation the low frequency message signal is carried by the high frequency carrier wave. So because of it attenuates lesser in the channel. So the long distance communication becomes possible because of this lower level of attenuation, since it has higher frequency after modulation. These higher frequency attenuates lesser. Now comes the last benefit that we will discuss, the improved signal quality at the receiving end. Improved signal quality at the receiver. Okay, this is the last benefit of modulation that we will discuss here. So how it affects the signal quality. In modulation, there are various types of techniques like frequency modulation, FM, pulse code modulation, in short known as PCM, etc., which can be used to reduce the effect of noise on the signal when it travels through the medium. This reduced effect of noise results in the improved quality of the received signal at the receiving end. Got it? So I have here mentioned few techniques like frequency modulation, also known as FM in short, and pulse code modulation, PCM. These are very important techniques which help in the reduction of noise. Okay, so as the noise is eliminated or reduced to great extent by using these techniques, and there may be some others also, the improved signal quality is obtained at the receiving end. So these were the advantages of using modulation process for the transmission of signals. If you have any suggestion or question regarding this video, then feel free to write in the comments. To get notification of my latest videos, you can subscribe my channel Engineering Made Easy. Okay, thanks for watching. Bye.